In this video, I'll explain how to merge data frames in the R programming language. In the video, I will show you different topics, and in the first section of this video, I will explain different types of joins. Then in the next part of the tutorial, I will explain how to merge data frames using the basic installation of the R programming language. Then in the next part, I will show how to merge data frames using the dplyr package. And in the last part of the tutorial, I will compare base R and the dplyr package in terms of speed. So without too much talk, let's dive into the first part of this video. So in this first step of the tutorial, I want to explain some of the most common types of joins that you can apply to merge your data frames. So in this sheet that you can see right now, you can see two different data frames at the top. So our first data frame is shown in purple and the second data frame is shown in orange. And as you can see, both of our data frames contain an ID column which identifies different observations in our data. And as you can see, the first data frame contains the IDs number 1 and number 2. And the second data frame contains the IDs number 2 and number 3. So here in this case, you have to note that the ID number 2 is existing in both data frames, but the ID number 1 is only existing in the first data frame, and the ID number 3 is only existing in the second data frame. And then both of our data frames contain values. So the first data frame contains the values stored in a variable called x1. And the second data frame contains the values stored in a variable called x2. So now in this first step of the tutorial, I want to explain 4 different types of joins. So the first type of join that I want to show you is the inner join that you can see at the bottom left. And if an inner join is used, only those IDs are kept which are existing in both data frames. So as I have explained before, only the ID number 2 is existing in both data frames. And for that reason, if we apply an inner join to our 2 example data frames, only the values stored in the ID number 2 are kept in the merged version of our data frame. So here you can see we have the ID number 2. Then we have the corresponding values in the variable x1, so the value a2 that you can also see here at the top in the first data frame, and the value b1 in the second column x2 that you can also see here at the top in the second data frame. Another way on how to merge data frames is provided by the left join, as you can see here in the middle of the tutorial. And as you can see, the left join keeps all rows of the first data frame, but only the rows of the second data frame that are also consisting in the first data frame. So in this case, the ID number 1 is only existing in the first data frame, and for that reason, this value is still kept in our data, but the value in the second column x2 is set to NA, so NA stands for not available. And the second ID is also kept in the data because this ID is existing in both data frames. However, the third ID that you can see at the top right in our second data frame is not kept in the merged version of our data frame because this ID is only existing in the second data frame. A similar approach is provided by the right join that you can see at the bottom right. And in this case, all the rows of the second data frame are kept, but only the rows of the first data frame that have an ID in both data frames. So in this case, the first row is removed because it is only stored in the first data frame, but the second and the third rows are kept in our merged data frame. The fourth version that I want to explain in this video is the full join that you can see at the bottom right. And the full join is keeping the most possible data of our 2 input data frames. So in this case, all the rows are kept. And as you can see, the first ID has an NA value in the second column, and the third ID has an NA value in the third column. but all the data that was stored in our two input data frames has been kept in the merged version of our data frame. So in this first section of the tutorial, I wanted to show you different ways on how to join data frames. And now in the next section, we will apply these different types of joins in practice in the R programming language. So as you can see, I have now opened RStudio, and the second section of this tutorial, where we create some example data, is shown in lines 2 to 10 of the code. So in these lines of code, we are creating two data sets, and the first data set is created in lines 4 to 6. So if you run these lines of code, you can see at the top right of RStudio that a new data frame object appears at the top right of RStudio, which is called data A. And we can click on this data frame to see the structure of our data frame. And as you can see, our example data frame contains an ID column with IDs ID1 to ID6 and two columns that are containing some values. Then in lines 8 to 10, we can create a second data frame, which is called data B. So after running these lines of code, another data frame object appears at the top right of RStudio, which is called data B. And if you click on this data object, another window appears, which is showing the structure of our second data frame. And as you can see, this data frame also contains an ID column. However, this time the IDs are ranging from the ID number 4 to ID number 9. And then you can also see that this data frame contains two additional columns, which are also containing values. So at this point of the tutorial, we have created our two example data frames, and now we can continue to merge these two data frames into one single data frame. And in the next section of this tutorial, starting at line 12, we will use the basic installation of the R programming language to merge our data. And the basic installation of the R programming language provides the merge function, as you can see, for instance, in line 14 of the code. And within the merge function, we have to specify how we want to merge our data. So if you remember the first section of this tutorial, where I have explained the different types of joins, then you might remember that the most simplest type of join is the inner join. And we are applying an inner join in line 14 of the code. And we can do that by applying the merge function to our two data frames. So you have to specify the names of our two data frames at the beginning of the function. And then you also need to specify the by argument. And the by argument is used to specify the name of the ID column. So in this case, the ID column of our two data frames is called ID. And for that reason, you need to specify a character string containing this name of our ID column. And then we are storing the output of the merge function in a new data frame object, which is called database inner. So if you run line 14 of the code, you can see at the top right of RStudio that a new data frame object appears, which is called database inner. And if you click on this data frame, you can see that a new window appears, which is showing the structure of our merged data frame. And as you can see, this new data frame contains only 3 rows with the IDs number 4, 5, and 6. But now the new data frame contains 5 columns instead of only 3, because it still contains the ID column that we have used to merge our data. And then it contains also the values of the variables x1 and x2, which were stored in the first data frame, and the values of the second data frame y1 and y2. So in this first merging process, we have used an inner join. However, the merge function can also be specified slightly differently to apply different types of joins. And in the next line, in line 15 of the code, I want to show you how to use a left join to join our data frames. And the only difference of line 15 compared to line 14 is that we are also specifying the all.x argument to be equal to true. And we have also changed the name of our output data frame. So in this case, our data will be stored in a data frame called database left. So if you run line 15 of the code, you can see that another data frame appears at the top right of RStudio, which is called database left. And if you click on this data frame, another window is opened, and as you can see, this data frame contains more rows, because now also the rows that are only contained in the first data frame but not in the second data frame have been kept. So you can see that the IDs number 1, 2 and 3 are still existing in the merged version of the data frame, and you can see that the values in the columns y1 and y2 have been set to NA, because these IDs have not been stored in the second data frame. Similar to that, we can apply the code that you can see in line 16, and all we are changing here is that we are now using the all.y argument instead of the all.x argument. So if you run line 16 of the code, another data frame appears at the top right of RStudio, which is called database write. And if you click on this data frame, you can see that we have created another merged version of our data frame, and this time the IDs number 1, 2 and 3 are not stored in the merged version of our data, but instead the IDs number 7, 8 and 9 are kept, and this time the NA values have been assigned to the columns x1 and x2. Yeah, and last but not least, we can also apply a full join to our data. And for that, we only need to specify the all argument. So compare that to the previous two rows. In line 15, we have used the all.x argument. In line 16, we have used the all.y argument. And now we are simply using the all argument. So if you run line 17 of the code, another data frame is appearing at the top right. And if you click on this data frame, you can see that another window appears, which is showing all our data. And as you can see, the values in the IDs number 1, 2 and 3 are set to NA in the columns y1 and y2. And the values in the columns x1 and x2 are set to NA for the IDs number 7, 8 and 9. So as you have seen in this section, we can use the functions of the basic installation of the R programming language to create different types of joins of our data. However, I want to show you another section in which I'm using the functions of the dplyr package to merge our data. Because the dplyr package is a very powerful package when it comes to data manipulation in R, and for that reason many people prefer to work with the dplyr package instead of the basic installation of the R programming language. So the dplyr section is starting at line 19 of the code, and in order to use the functions of the dplyr package, we also need to install and load the dplyr package. I have already installed the package, so for that reason I'm just going to load it with the library function. However, in case you have not installed the dplyr package yet, you can also install it using the install packages function, as you can see in line 21 of the code. As I said, I have already done that, so for that reason I don't need this line of code. However, I still need to load the package, as you can see in line 22. So after running this line of code, we can use the functions of the dplyr package, such as, for instance, the function inner join, as you can see in line 24 of the code. And as the name of the function says, with the inner join function, we are applying an inner join to our data. And within the inner join function, we can specify the same as before in case of the merge function. So we need to specify the name of our first data frame, the name of our second data frame, and the ID column that we want to use to merge our data. So if you run line 24 of the code, you can see that another data frame object appears at the top right of RStudio, which is called data dplyr inner. So if you click on this data frame, you can see that we have created exactly the same data output as in the very first application of the merge function in the previous section. However, this time we have used the functions of the dplyr package to create our merged version of our data frame. Similar to that, the dplyr package provides other functions for different types of joins, such as left join, right join, and full join. So the difference of the functions of the dplyr package compared to the basic installation to the merge function is that in case of the merge function, we need to specify the type of join that we want to use within the merge function. and in case of the dplyr package, a function is provided for each type of join that we can use. So if you run lines 25 to 27 of the code, 3 more data objects are appearing at the top right of RStudio, which contain exactly the same values as in case of the left, the right and the full joins that we have applied before using the merge function. So at this point of the tutorial, you might wonder why we even need the dplyr package, because if we can achieve exactly the same with the basic installation of the R programming language, it's not really necessary to install and load the functions of the dplyr package and to apply the functions that are provided by this package. And for that reason, I want to show you another section in this tutorial in which I'm comparing the two packages, or more precisely, in which I'm comparing the speed of the two packages. And this section is starting in line 29 of the code. And in the beginning of this section, I'm going to create 2 new data sets. And the reason for that is that the speed of a join application is only important in case you are using large data sets. And the 2 data sets that we have used before contain only of 6 observations each. And for that reason, we will not notice any difference in the speed of the 2 functions when we are merging small data sets. So in lines 31 to 40 of the code, I'm creating 2 data sets that consist of 10 million observations each. And furthermore, in these data sets, I will simulate normally and uniformly distributed data by using the rnorm and the runif functions. And always when random processes are involved, it makes a lot of sense to set a random seed to provide reproducibility of the code. And this is what we are doing in line 31. Then we are specifying the sample size of 10 million cases in line 32. And then after running lines 34 to 36 of the code, another data set appears at the top right of RStudio, which is called data A large. And after running lines 38 to 40 of the code, another data set is appearing at the top right of RStudio, which is called data B large. I'm not going to open these data sets because since these data sets are so large, it might take some time to load them in R. However, you can see the number of observations at the top right of RStudio, because as you can see, our previous data sets consist of 6 observations, and data A large and data B large consist of 10 million observations each. So in the next step of this section, starting in line 42 to 45 of the code, I'm using the Sys.time function to measure the time of our merge application. So more precisely, at the beginning in line 42, I'm measuring the system time before we are applying the merge function in line 43. In line 44, I'm measuring the system time after the application of the merge function. And in line 45, I'm measuring the time difference between the finishing time and the starting time. So this will give us the overall time that was needed to merge our 2 data sets with the merge function. So if we run lines 42 to 45 all together, you will see that a small stop sign appears at the bottom in RStudio, and this tells us that R is currently calculating something. And as you can see, the stop sign is still appearing because it takes a lot of time to merge our data sets using the merge function. Now the stop sign disappeared, and as you can see at the bottom in the RStudio console, the sentence time difference of 19.3079 seconds has been returned. And this tells us that it took us more than 19 seconds to merge our data frames. So in the next step, I want to compare that with the inner join function of the dplyr package. So the lines 47, 49 and 50 are basically the same as lines 42, 43 and 45. So in these lines we are measuring the time. However, in between, I'm using this time the inner join function instead of the merge function to combine our 2 data frames. So if you run lines 47 to 50 of the code, you can see that the stop sign appears again at the bottom in RStudio. However, as you can see, the stop sign disappears after 5.35 seconds because the dplyr package took only 5.35 seconds to merge our data frames. So if you compare the times of the merging process of the merge function compared to the dplyr package, you can see that it took almost 14 seconds more to merge our data using the basic installation of the R programming language. So even in case of the 10 million observations, you might say, I don't need this efficiency. I don't care if my merging process takes 14 seconds longer. However, the larger your data gets and the more complex your data gets, the longer it takes. And for that reason, it might be an advantage of the dplyr package that it's much faster than the basic installation of the R programming language. That's all I wanted to explain in this video. In case you want to learn more on this topic, you may check out my homepage, statisticsglobe.com, because on my homepage I have recently published a tutorial in which I'm explaining the content of this video in some more detail. I will put a link to this tutorial into the description of the video so you can find it there. If you have liked this video or if you have any questions, let me know in the comments section below. I'll try to respond to all comments as soon as I can. Furthermore, make sure to subscribe to my YouTube channel to get notified about future video releases. I have already published about 500 videos on this channel and I'm releasing new videos on a daily basis. Thanks a lot for watching. See you in the next video.